Hello guys, welcome to Smart Interviews YouTube channel. In this video, we'll be discussing LeetCode Biweekly Contest 132 solutions. Now, we'll jump into the first question, clear digits. You have to remove all the digits by following this operation repeatedly. So you have to delete the first digit and the closest non-digit character to its left. So first, we'll look into these examples to understand it more carefully. If you look at this sample input, first character is not a digit, so you'll be simply adding to the you'll be simply traversing it to the next character, and you will be adding that into the resultant array. And is b is still a non-digit character, simply add it to the result, move to the next, and you'll be having resultant as abc. Now we'll go to the next sample input, second sample input. What is your string? String is c, b, 3 and 4. If you look at this example, what is your first character? First character is non-digit, so you will be adding that to the string. And what is your next character? Next character is b, so you'll be adding simply into the resultant string. What is your next character? It is a digit, so if it is a digit, then you have to remove the leftmost character. What is the leftmost character? It is b, so you'll be removing this and you'll be not adding the digit into the resultant. Now again you'll be moving to the 4, last character, and as it is a digit, you'll be not adding that into the result, and also you'll be checking whether there is a leftmost non-digit character. Is there any leftmost non-digit character? Yes. So simply you'll be removing that, and you'll be left with empty string. So you'll be returning empty string as the output. You'll be printing empty string as an output. So what approach can we follow for this logic? So if you look carefully, we can use stack data structure for this. So what if we are using stack data structure? Let's say you are having a stack, and let us go with the second example. So you are having c. If it is a non-digit character, push simply into the simply into the stack. Now next character is b, simply push into the stack. What is your next character? It is a non-digit. So if it is a non-digit, what you will do is you will be trying to push, you will be not pushing this 3 into the stack, and also you'll be removing the topmost character from the stack. So you will be simply having c inside the stack. Now what is your next step? Your next step is you'll be having, what is your next character? Your next character is 4. As your next character is 4, you will be simply popping the top of the stack, that is c, and you have completed traversing entire string. Now you will try to traverse all the characters which are present in the stack. What are the characters present in the stack? There are no characters present in the stack, so you'll be printing empty string. So similarly, if you try to dry run the first example, you'll be pushing A, B and C. As there are no digits, so you'll simply try to pop all the characters from the stack, and you'll be having C, B and A. Will you print in this order or in the reverse order? We'll definitely try to print in the reverse order. So what will be the output of the string? It will be A, B and C. So this is a logic based by using stacks. Okay. So what is the space and time complexity? You are using additional space. It will be big O of n, and time also, as you are traversing entire array, you will be having n comma n solution, that is time complexity and space complexity respectively. So let us try to code this approach. So if you try to code this approach, we are having stack First, let us try to declare a stack, and next we are traversing on the string. You can simply write n and I plus plus. What is your next thing? If is digit, what are you checking? Is it a digit? So if it is a digit and if your stack is not empty, now what is your next thing? You will be simply trying to pop the element from the stack. Else, what you are going to do? Else, you are simply trying to push the present character, that is s of I. And at last, you will be simply using an extra string, resultant string. For this resultant string, you'll be checking whether stack is empty or not. If it is not empty, then simply you are going to append or add top stack element and then pop it. At last, you can return resultant, and this is how we are trying to code the logic which we have reversed. So will you directly return the result? As we have seen the example, we have to reverse the string, that is whatever the thing we have got. We can use the inbuilt function in this C++ and we can result the string, reverse the string. So it is accepted, and let us try to submit it. So it has been submitted for all the cases. Now, is there any other approach that we can optimize the space for this? So if you look carefully, you're having string, and if you're having string ABC, whenever it is not a whenever it is non-digit, you are simply trying to push that into a another string, right? That is another string, you are trying to append that into a another string. So similarly, you'll be appending A, B, and next time you are going to append C. For the last example, if you look carefully at the second test case, in the resultant you'll be having C and B. Whenever you see 3, that is a digit, you will try to pop the last element from the resultant. How can you do? You will have the inbuilt function pop back in C++. In your other languages also you'll be having some feature, so you can simply use that and try to remove the last character of the resultant string. So if you remove it, you'll be left with C, and again you'll be traversing into the next character, which is again a digit, and again you will be removing C. So in this way, your time and space complexity, you can optimize that to n comma 1, because you are not using any other external space like stack in this logic. You are simply using popback, and you are trying to just remove the last character in your resultant string. So let us try to code this logic. So we'll try to reset this and we'll try to code. So we'll traverse definitely for n times. We can simply do h dot size here, and we are traversing for n times. What is your next thing? First, you'll be checking whether it is not a digit or not. So you'll be checking particular character is not a digit or not. If it is not a digit, then simply you are going to append that into the resultant. Yes. After appending that into the resultant, what is your next step? If it is a digit, you are going to pop back the last character from the resultant string. At last, you will be returning resultant. Any other thing? Because as we are using while loop, we have to take care about incrementing our I. And let us try to submit it. Yes, we have this got accepted for all the test cases. Here we have to find the first player to win the K games in a row. So there is a competition, and in this competition the players are numbered from 0 to n-1, and you are given an array of skills. So it is a positive integer, and there you will be having the skill level of player I. So important thing here is all the integers in the skills are unique, and if you look at the constraints, n is 10 power 5, till 10 power 5 it is there, and k, it can be 10 power 9. So consecutive things can be 10 power 9. What is our process? What process we are going to follow? The first two players in the queue will play the game. The player who is of higher level will win. So we'll look at the first example and try to understand the process and simulate the process by using the examples. So first we are given 4, 2, 6, 3 and 9. First two players in the queue will play the game. So if 4 and 2 plays the game, who is going to win? Definitely 4 is going to win, right? So whoever is going to win will stay at the front, and whoever going to lose will move to the back. So according to here, 2 moves to the end of the array. Now, what are the first two elements? 4 and 6. So what is, how many times 4 has 1? Till here 4 has 1 for one time. Okay, count is 1 for this. And now what happens for the next iteration? Who is going to move and who is going to win? That means who is going to move last? Whoever is going to lose is going to move last. So according, when these two players play, 4 is definitely going to lose, so it will move to the end. If it move to the end, what are we left with? 4, here will be left with 6, 3, 9, 2 and 4. So we are left with this array. In this way, in the next iteration also 6 is going to win. So count here will be 2, because first time 6 is going to win here, then your count will be 1 here, and next time also 6 is going to win here, and your count will be 2. So in this way we can clearly say you have already won for 2 times, that is for k times. Now what you are going to return? Are you going to return 6? No. So actually we are going to return the index of 6. So which is better to store in our array? Is it values or indices? So better we can store the indices rather than the values. So if you store the indices, and if you push the indices at the last, then we can easily compare those, access those values and compare those elements. So first thing, what we have to do, we'll compare the first two things in the queue and we'll move to the last. Yes, and if whoever is losing will move that index to the last, and again we'll compare the first two elements, which other element is smaller, we'll move that particular index to the last. So this is the process we are going to follow. And now if you look carefully this example, who is going to win? 6 is going to win, and we'll return the index 2. We'll move to the next example. If you move to the next example, this 2, 5 and 4. And what are the indices for this? We are having only 3 indices, that is 0 to 2. Now if you try to compare clearly, you'll compare 5 and 2. And what is smaller element? Smaller one is 2. We'll try to push the 2 to the end of the array. And we are left with 5, 4. Still we'll compare this, and definitely again 5 is going to win, and we'll move 4 to the last of the array. Even if we do for another time, 5 is only going to win. What is the observation here? If you clearly observe, here 5 is the maximum element in the entire array. in array. So if we are having the winner as the maximum element in the array at any point of time, even if the k is 1, 2, 3, 4, so that player is definitely going to beat everyone. So we can simply return the index of the maximum element. Is it clear? So we have found two things here. First thing is, we are going to, whoever is going to lose, we are placing that index at the last. Instead of element, we can place the indices here. And here in the same way, here whenever we have whenever we have seen the maximum element in the array, we are simply going to return it, because it does not matter whatever the element is going to come next, definitely that will be your answer, that index will be your answer. So how, what data structure will be useful to push an element to the starting and push an element to the last, and also we have to remove the element from the front and we have to push the element to the back. So what type of data structure is most suitable for this problem? If you carefully observe, we can use doubly ended queues. This is known as deck. So by using this deck data structure, we can solve this problem. So first, what we are going to store, we are simply going to store all the indices of the array. And next, we are maintaining the counter variable. And whenever this counter variable reaches n, we'll simply return that index. Else, if the present element itself is a maximum element in an array, we'll simply return that index. So we will continue this process till we satisfy any of these both conditions. So we'll try to take deck. So we'll try to come take this process till we have reached till we satisfy any of those conditions, right? So first we'll take the front element. Let us name it as first, and next we'll remove it. What is the next step? Take the second element, and these all are indices, not the elements. Make sure you are noting that point. What is the next step? So if skills of first is greater than skills of second, then what you are going to do? You are going to increment your counter. Else, what is your next thing? So you will be making your updating your first with second. This is one thing, and you will be making your counter as 1. Is it clear? Now you will be checking those conditions which we have discussed. If count is equals to k, or if count is equals to the maximum element. So how can we find the maximum element in the array? So in further, we have inbuilt function in C++. Similarly, you'll have the inbuilt function so that you can complete the code fastly. We'll use max element to find the maximum element in an vector. We have completed this, and now what's the next step? You will be simply returning the first where your answer lies. So this is what we have done. So if first person is having if that person is going to win, we are making sure you are incrementing your count. And if that count reaches k, or if not count is equals to maxi, it is skills of the first element, that is whatever the element we are storing, whichever element is greatest till this point, that one we are comparing whether it is equals to the maximum element in the vector. If it is equal, then simply we can return that one. So we'll try to run the code. So here is the typo, it is skills, and yeah, and we have passed the sample test cases. Now we'll try to submit the code for other test cases. Yes, we are done with this, and we'll move to the explanation still. So can we do this, solve this problem without using deck? With the present observations, can we solve this problem without using deck? 4, 2, 6, 3, and 9. So what are the indices here? Let's say you are comparing 0th and first index. So which one is maximum? 0. So definitely your 2 will move to the back of the array, end of the array. And what is your next thing? If you try to compare 4 and 6, your definitely your 6 is greater than 4, and you will be storing the index 2 here. So here 4 goes to the end of the array. Now you will be comparing 6 and 2, 6 and 3. 6 is greater. Now again the 6 is winning for 2 times. So we can simply return your index as 2. And is there any requirement to traverse more than n elements? Is there any requirement to traverse more than n times for this problem? If you look carefully, if the present 6, that count is 2 here, that is it is winning, player 2 is winning for consecutively for 2 times, then we can simply return your answer as 2. Whereas what is your k here? K is 10 power 9, right? So if you are having any maximum element in your array, let's suppose if maximum element is 9, and if your k is somewhere around 10 power 9, 1e9, so we can simply say whenever you reach the maximum element, you can have that k equals to 10 power 9, right? So if k is equals to 10 power 9, we can simply say your answer is the maximum element in your array, because definitely whatever the elements comes, you will be having this maximum element as your answer, and you will be returning index as 4, answer as 4, or index as 4. And if you look carefully, there is no need of traversing for more than n times for the given example. So what we are going to do here, first thing, so let us name our first player as 0th index, and we'll start with 1, and we'll have the same parameter here. If skills of I is, that is first, is greater than skills of I, we can simply say who is going to win. We are simply trying to increment that. Else we are making our count as 1 and your first as I. Okay, so this is same as your second, as we have seen in the last approach. Now what you are going to return, if count is equals to k, you are simply going to return your first, right? At last, whatever the greatest element is there, even if it is not returning for any time, whatever the element that is maximum element is present, we are simply going to return that maximum element, because this simply stores the greatest element, right, in the given array. Now we can simply return the index of it. So we'll try to run the code. It has been accepted for sample 1, and now we'll submit it for all the elements. So it has parsed for all the cases, and these are the two different approaches for this problem. In this problem, you are given an integer array nums and a non-negative integer k. So there is a definition of good subsequence. A subsequence is said to be good if the adjacent element, if there are adjacent elements which are not equal, we can only include, or we can only take at most k indices with that condition. So if you look at the first test case, that is having 1, 2, 1, double 1 and 3, and your k is 2 here. So what you can include? Can you include 0th index? Yes, if you include 0th index, it will be 1. And whenever you are trying to include your next index, you'll compare them whether they are equal or not. As 1 is not equals to 2, we'll decrement our k to 1, and we'll try to include our first index. Now your pointing your present index is 2 here. So, and your next index is 1. So if you try to include 1, then your k becomes 0, right? So let us try to include it. And next index is 1. So even if you include it, there is no need of decrementing k, because the condition for having at most k here is only when they are not equal. So if they are equal, there is no need of decrementing k or adding that decrementing that k. So you'll include the 1, and your next index is 3, but your case, that is at most case, which you can use, is already completed. Now your length of the subsequence will be 4 for this given example. This is the best possible scenario for the first sample test case. If you look at the next one, if it is having 1 here, if you try to include 2, already k is 0, so you cannot include 2, 3, 4, 5, only you can include again 1. So what is your length of the subsequence? It is simply 2. So this is the best possible subsequence for the given example. Now let us try to look what are the possible approaches to solve this problem. Now if you look at the constraints, n is 500 and k is minimum of n and 25. So it can be till 25. So it can be till 25. So n is 500 and k is minimum of n comma 25. Now this is the problem statement for this question. Now how can you solve this question? So if you look, what is the brute force approach which comes to your mind here? Simply, if there are n possible places, there is 2 options for every position. You can either pick it or not pick that element. So you'll be having 2 power n, but if you look at the given constraints, it will be 2 power 500 and it will definitely give you TLE. So we cannot generate all the subsequence and follow this condition. So what is the best alternative? So how can we optimize, or what is the alternative approach for this problem? First thing, let us try to figure out the DP expression for this. So let's say this is ith position. If it is the ith position here, now you can traverse from 0 to I-1, or you can compare I-1 here, I-1 with I minus 2 and all those things. What happens if ith position is equals to I minus 1 position? So if you say nums of ith position is equals to nums of I minus 1, so you can simply say that you will be incrementing your I, and whatever the db state will be there, you will be simply incrementing it by 1. That means you will be incrementing your length by 1 in this case. What about the other case, that is nums of I is not equals to nums of I minus 1? What about this case? In this case, will you just depend upon the previous one to increment? So what you can do here, so for this, if you look here, we are trying to include the element and increase length by 1. If it is not equal, then what you can do? If it is not equal, then you can have two choices. If you try to include it, you can increase length by 1. What is the other case? And what happens if you increase your length by 1? You have to decrement your k by 1. You should also decrement k by 1. What is the next case? If you try to exclude, what is going to happen here? So if you are trying to exclude here, you'll be at the same position, right? So when you are going to exclude that element, so if k is greater than 0, if it is k is greater than 0, will you include or exclude? We will definitely try to include here. So whenever you try to include, there must be some condition. That condition is k is greater than 0. If k is equals to 0, definitely you cannot include that element and you will be excluding it. So k is less than or equals to 0, you will be excluding it and you will be not incrementing your length by 1. So these are the two cases. Now if you look at this example, so what are the parameters it is depending upon? So if you take parameters for your recursive call, so what are the things it is depending upon? Your previous index, definitely your previous index, and your remaining k, whatever the k it is remaining for, which is available for the next call, and your given vector. So these are the three parameters it is depending upon. So let us, if you have understood the logic, try to pause the video and try to write the code by using recursion. So let us try to code whatever we have discussed. And now first thing, we'll declare n globally so that we can reduce some parameters inside our recursive call. What is your next thing? We'll try to initialize it, and as recursive calls will be having 2 power n, so to optimize it, definitely we'll try to use memoization. So we'll use memoization. We'll initialize dp of n plus 1 and minimum of n plus 1 comma 26, because as it is equals to 25, so we have to include it, so your size of the array can be 26 there. So these are the two parameters it is depending upon. First is array size and other is of k, and we'll try to initialize this entire thing with -1 initially. So whenever you find this, whenever you reach this answer, we'll try to store it, and we'll try not to do recursive calls if it is already visited, or you can say if answer is already present for this state. So we'll initialize this with -1, and we'll declare the vector of vector globally, and here memo will be n+1, and you'll be having vector of int n+1 and minimum of, sorry, it will be minimum of n+1 comma 26, and you'll try to initialize this entire thing with -1. This is, we have done with the initialization. And now what is your next thing? Your next thing is to find the maximum length. If you look at the constraints carefully, your length is starting from 1, minimum length is 1, so you can initialize your maximum length with 1, and you can start your array for n times. You can traverse your array for n times. In this thing, you can take the helper function, that is recursive function with memoization. So what are the things required? Current index and your k and your nums. So these are the things which are required for your helper function. Now how do you use your helper function? So you'll write helper here, and first thing your current index, next thing your remaining k, and your vector with nums. So what is your, whenever you write the recursive call, we'll move with the main logic here. What is our main logic? So your previous index will start from current -1, and previous will be traversing in the reverse direction. Now in this case, we have two cases as we have already discussed. First thing, we can initialize our maximum length with 1. What are those two cases? If nums of current is equal to nums of previous, what you are going to do? You can simply include that element. There is no condition for this. We can use this to increase our length of our subsequence, and here you can simply include it. If you try to include it, what will be your next current? The current index, that is previous. And will you decrement your remaining k? As we have already discussed, if it is equal, there is no need of decreasing your k value, and just will pass the parameters as it is here. And else, in the case of else if, that means whenever you are writing this, it already, we can already say that it is not equal. If it comes to here, it is already not equal. Now what is the other condition we have to write to include the next next element? If it is not equal, we should mention the condition. If we should check the condition if remaining k is greater than or equals to greater than 0. If it is greater than 0, then we can include it, and we can increase the size, and this helper function we can make it previous and remaining k -1 equal, and decrement the remaining k, and that's it. Now we are using memoization. Whenever we complete this entire thing, try to store the answer for the present state. Whatever the state it is there, try to store that answer. So we are done with the main logic. Now what can be our base conditions? Our base condition should be, if current is equals to n, we'll be returning 0. And as we are using memoization, so to avoid the repetitive calls, we can check here itself if memoization of current and remaining key is equals to -1. If it is equals to -1, it should simply return current and whatever the remaining k is there. If it is not equals to -1, if it is equals to -1, that means we have not stored that answer. Then we'll do all these recursive calls again. So let us try to run the code. So there is a compilation error and there's a typo here. It is max length. Let us run it again. Still okay. We have forgot to write the return statement. So if you look here carefully, there is compilation error, that is vector memo minimum of n plus 1 comma 26. We are initializing n plus 26 minus 1 here with -1, and actually we have already declared it. There is no need of writing memo again here. At last here again we have to return max length. Yep. So sample cases has been accepted. Now let us check with the other cases. Yeah, it has been passed for all the cases. And let us look into the time complexity for this example. So what can be the time complexity for this? If you look at this code, carefully, so if you look at the code in the helper function, we are having a for loop which is traversing previous from current -1 to previous is less than or equals to the previous and greater than or equals to 0, I minus minus, and it is depending upon the current and remaining key. So definitely both the parameters are changing. So current is changing and remaining k is also changing when they are not equal. So this helper function itself, so all these recursive calls itself will be taking current into, that is current into remaining k. Remaining k is nothing but k here, and what is the maximum value of this? N into k. So all the recursive code what we have written in this inside this for loop, they are changing according to the current and remaining k. So it is n into k here, and this outer for loop is also having time complexity of n. Maximum time complexity can be here is n. So this helper function itself is taking n square into k. But if you look at the normal function which we are calling from, that is from maximum length function, we are using for loop, right? So we are using for loop here, and inside this for loop we are traversing for n times, and here you are having helper function. So helper function itself is taking n square into k time. What about what about this for loop? Inside the for loop, will you say it as n cube into k? No. Why it is not n cube into k and it is n square into k? What is the reason for this? Because we are going to visit current and remaining k only for once. We are going to compute the results for present k, current k and remaining k, current index and remaining k only for once. That's the reason your time complexity here is n square into k. So if you look at the constraints carefully, why only we are visiting it for once? Because we are using memoization. So if it is already present, we'll be simply returning it. Again, we are not going to compute that value again. So look at the constraints here. So for n square into k, if you look at the constraints, it is 500 into 500 into 25. So it is something like 625 into 10 power 4. We can write it as 6.25 into 10 power 6. So it will be accepted. It will be giving you, the solution will be accepted because of this. So this is all about this question. And one more thing, what is that space complexity? It is n into k. So that's all for this problem. Thanks for watching the video. For more such content, subscribe Smart Interviews YouTube channel. Do share and like this video if you found it informative. Until next time, this is Karthik signing off.